Hello guys, I hope you have been well. So I know it has been quite a bit, it has been long before I uploaded something. So today we want to touch on particle stress, especially in von Mises. When you compress particles, they undergo stresses, and we want to calculate the stresses that this particle undergo using EDM. So to start with, we'll need custom API, of course. Now, let us go now to the folder. So this is where we want to do our tutorial, particle stress tutorial. So I have my particle stress DLL, and I also have my preference file. So now I realize that EDM, they merged with Altair engineering. So you can always access those files from there, but you have to be a customer. So now the next thing that we have to do now, we create our project and we save it here. So we save our project. So you navigate to documents, EDM, particle stress and not particle stress here. So we call this particle stress tutorial, like that. So we need two particles. So but now we create our bulk material. So we want to use granite. So now we add our particle, add our particle shape, not particle shape, our particle 1. So remember these particles, the way you name them, if we have 3 particles, so we have to name them according to our preference file. For instance, let us go now to our preference file. So we have our preference file. So we want 2 particles. So we have particle A and particle B. So they have to be in the same order. For instance, you cannot name this as particle B. It's not advisable. So your first particle should be particle A in the same order that you put them in your preference file. So you have particle A and you have B only. So I put this so that you can distinguish, and you have number of particles as 2. So if you have 3, you change 3 and then you add the name of the particle here. So the thing that I can ask you to do, go and check if you can also replicate the same if you have different bulk materials. Now, without further ado, let us go now to renaming this particle A, and also we can add material, add particle, not material, we add another particle. So we call this B, like that. Now size distribution. So we don't want this to be in this shape. So we can always change this shape. And please note, I'm using EDM. I'm using EDM 2020. It's not 2021. It's 2020, and it's not like the previous one that I've been using. So you come here to modify shape. So it's not like the previous one, 2018. So I've upgraded to 2020. Now here we want a radius of 15. A radius of 15, yes. And we don't need any contact radius, so it's okay. Now we click default. And particle A, we need a radius of 20. That means a diameter of 40. Click default and we save our work. Now we add the properties, the densities here. So we put here 0.35. So we have to recalculate this because we've not put auto calculate. So here, so we put 5.571. So you just come here to avoid any errors, just put auto calculation like that. So anything you change here, it auto calculates. So now we add equipment material. Now we don't need to open that, we just add. So we call this steel. Put the properties as I'm doing. Zero Poisson's ratio 7800. This we put 700 E, and that is 7 E per 10. Now we put the interactions, so you can just come here and put your interactions. So granite to granite, we want the following interactions. One for static, coefficient of restitution first. So we put 0.2. For static, let it remain the way it is. For rolling friction, let it remain the way it is. And now we add another for steel. Now here we put for static. For restitution 0.25. For static we put 0.7, like that. Coefficient of rolling friction, it remains the way it is. Now the next thing that we need to do is to add our geometries. Now we have our box. So our box we put, now this will also be a factory. Remember, the factory doesn't have to be virtual. So this can also be a factory because it's hollow. It's a void inside there. It's not completely filled. But if you want to have a different type of factory here at the top, so that the particles will fall down, you can just always create another factory inside there. The main reason I'm doing this is because we'll have our control here. As we compress the particles, we'll have our control section here, so that we see there is that difference. Now in EDEM 2020, if you want to change the dimensions, you come here to transform, here, not the directions, the position. So but here for the direction, you can just come, for the size you just leave it 1000 by 1000 by 1000 millimeters, because we're using millimeters. So if you want to reposition anything, you can just come here. Even if you want to rotate, you can just come here at transform. Now for the mass, it will auto calculate from your properties. You see how we are still properties here, so it will auto calculate even the moment of inertia and the second moment of inertia. It will calculate everything. Now the next thing that we have to do, just come here, just add another cylinder. Now this will be our control. Now we call this control cylinder, because we want to see is there a difference between the two. Now at start, radius at start, we put 500, because it's starting from the bottom up. And then here we put 200. No, let us put 250. And then the length you can put at 250, like that. So but we want to reposition this so that it goes to the bottom part. So we just come here, transform, and then in the z axis -375, like that. So as you can see, now we have transformed. So if you want to rotate, you can always rotate. Remember, even the rotation, you can change from radians to degrees. So for instance, this just, by the way, let us go now to units, and then we change angle from radians to degrees. So we want to rotate it. Maybe let's put something like 30 in the z degrees. As you can see, it has just twisted. So because the z axis is down on the up, so you have not, is not that significant observation. So let us try and change it in y axis. As you can see, it has twisted. So you can always change the degree that you want. Now because we are not interested in that, let us go now to the next part. Do we need a cylinder? No, we don't need a cylinder. So you can always delete polygon. So now this is the press. So we are going to press with this one. So we leave it at a square for sides, because we want it to completely fill this section, and automatically it's 1000 by 1000. So if you want to change the size, it's up to you. Now the next thing that we want to do, we want to reposition it to be here at the top. So we transform, we put, because the height is 1000, so you put at 500. So it will go at the topmost part. Now the next thing, so it has to be at the top here, because if it's outside here, it will not pass through. It will not pass through the box. It has to be here at the top. Even if you want to put it maybe a bit below, but here at the top it's okay, because now it's inside, it's kind of on the surface of the top face of the box. Now if you put it outside here, it will not pass through, because it's physical, the box is physical and it's also physical, so it will not pass through into the chamber that, or the void that we want to compress at. So now the next thing that we want to do, we want to add motion and linear translation. So now we come here, this, and then we put start time, then we put end time 0. 6, and then here we put 1 meters per second. And now the next thing that you want to do is to put the direction, because you don't have a direction. If you don't put the direction, it will not go anywhere. So we can put from start, let's say at 0, and then you can put at end. Because you want it to go down, you can put 200 minus 200, and you display the vector. As you can see, it's showing us the direction of rotation, as you can see. And as you can see, the reference point is local. So it has just the local axis, its own axis, not the global one. This is the global one. So if you want to change to global one, it's very easy, just do that. And then as you can see, also the Z and the start and the peak, the start and the end point, they are different. So if you put local, they change. So this just to show us the direction that we want. Now the next thing that you want to do is to come here, the box, and then we add our factory. I think I forgot that. We want it to be a static factory. The next tutorial that I'll do, I think I'll do a dynamic factory. So we change factory type. We let it fill section like that. And also the particles. For the particles, you just let them remain. If you want to change the composition of the particles, you can always, particle ratios, you can always come here. So for my case, I want 50 by 50, 50%. I want the number to be equal. Now the next thing that you want to do is to come and change the location, of our API. So we need the contact and the particle body first, because that's what we want. Now we don't need to change anything else or factories. So we want contact models. Now we come here, contact models. So we come here to the particle stress tutorial. That's what we want. And also we do that for the particle body force. Then we say, okay, and then you control save. Now here for the physics, under particle to particle, you come to edit contact chain. You remove this, you say no base model, and also for the rolling friction, no friction model. And then you put like that. So it will automatically put them in this order and leave them at that. And now for the particle to geometry, the same thing. You remove this, no rolling friction, no base model, then you add this one. So leave it at that. Now for the particle body force, we just edit contact chain and we just put one. It puts two options, but it's the same thing. And then you control, you save your work like that. Now come here, reduce the opacity 0.6, and now we can put this 0.6. And then we have to change this, the grid cell size. So we estimate it like that. Now we come to this step, so we put 10% so that we save on time. Now the next thing that we want to do, here you can decide to use GPU if you want to, or the CPU solver. So we can change the number of cores to 4 like that. And then we start our simulation. Now the simulation has completed. Yeah, so you can actually, during the simulation, you can refresh this. You can right click on the solved report and refresh so that you can see how much time it has taken. So it has taken about 30 minutes. So now let us go now to the analyst. So as usual, you change the opacity. So you just change, I like to put 0.6, I don't know why. Now we want to see how the simulation progressed. So we go back and then we click play. So that's how the particles were compressed, like that, up to that point. So the next thing that you want to do is to come to the particles. So, and then you want to color the particles by von Mises stress. As you can see, we have stress XY like that, XX in the XY. So you can color now by that. So usually you can just come to von Mises and then you put auto update like that. And then you show legend, apply all like that. So as you can see, there are some particles which have not been compressed, but as you can see here, there's that variation. So let us go back and then we put play. So as the compression progressed like that, Yes, as you can see. Now we want to see if it's only for one particle. As you can see, there is so much blue. So, and we don't want so much blue. So let us go now to, let us put these particles in uniform like that. And now we put particle A only. We want to color only particle A. We color by von Mises like that. As you can see, now particle B is the one that is in default color, the yellowish color. Now let us now return particle A to the uniform color, and now we do particle B by von Mises. As you can see, even for particle B, they have some stresses, so it's okay. Now let us return it to the uniform, and then we come to the particles, and then we color this by von Mises as we had done earlier. So now you can also change the legend options. So if you don't want in this power e power 6, so you can actually change from scientific to decimal floating notation, but for huge numbers it's always a good idea to put in scientific notation. Also for the decimals, even for the intervals, you can put 1, you can change the number of intervals. Here you have 1, 2, 3, 4, 5. You can put even 6, 7. It's up to you. Now it has cancelled it. Now the next thing that you want to do is to come and see if the control part worked as we wanted. So to do that, you just come to tools, and then you come, not to tools, sorry, you come to clipping. Just come to clipping. I want to slice, we want to clip. So you just click here, and then you clipping planes like that. So in this case, we want it's in X direction. So you can just put this default. Now you can just put like that in the X direction. So as you can see, we have clipped in the X direction. You can also change the distance from the center. Let's say 10. If we put 10 millimeters like that, it moves. Let me put in this way so that you can see well. So actually it was 0. So you can actually change it. You can reposition it 10 millimeters or minus 10. Now from the X axis, you see we are working from the X axis. Now we can even decide to change the clipping from the X axis to something else, to like Y axis. As you can see, it has cut from on the Y axis. Now we can even decide to put even in the Z axis. Put one like that. As you can see, it has cut like that. Even you can decide to cut in both axes like that. As you can see, the way it has done. So you can decide to, you can play with these numbers as much as you can. Even in the X and Y axis, both of them, you can do that. As you can see, the way it's doing. So you can play with this as much as you can. So even you can even add two axes. For instance, we have that one in X, and also you can add another one, clipping plane like that, clipping plane 2. And then now in this case, instead of having both in the X, now you can just put like that. So you can plane 1. No, sorry, let us remove this one. So here we have only one plane. Now we can add another plane here, plane 2. For plane 2, just come, put 0 and 1 like that. And now you see, now we have remained with a kind of a square. Okay, kind of a square. We have at 25% of the portion. But now we don't need this plane 2. Now let us now come to the control now. As you can see, there are some particles which have 0. The von Mises is 0 here because no compression took place. They were inside the control. When we said filled section, it filled the entire section, even inside the cylinder that we put. So let us go back. As you can see, the particles in the cylinder, they were not compressed at all. The color changes that you see are due to the impact forces once they hit the ground. Let us see. Now we are reversing. As you can see, once they hit the ground, once the particle hit the ground, that's when you see the color changes. But once they settle, the ones that go under compression, as you can see, they are the ones at the top. So if you want to compress more, they have the von Mises stresses. So the other thing that you can do, I want to show you something else. It's called slicing. If you want to slice a portion, so you can just put a slice like that. Now for the slice, you can even reposition it where you want it. Even you can change the depth. As you can see, this is 10 millimeters. So let us put something like 100 millimeters so that it's more visible. So as you can see, we have sliced that portion. So for a slice, it cuts a piece of it. So you can slice it and then you can analyze the von Mises or anything that you want to analyze in this portion. So let us put it back. Yes, as you can see, the particles inside the control or the dome that we've created, they are off at 0 von Mises stresses. Now, that marks the end. That marks the end of my video. That marks the end of my video. So if you like this content as usual, consider subscribing. Consider subscribing if you like this content and support the channel. So the next video that I'll do, it's probably on, I'll try and look for a video for dynamic factory. I've only been doing static factory, so we'll do dynamic factory. Yeah, thank you very much.